Hello, this is Vinay here, and I would like to present my project on Coursera, the module 2 of AI product management specialization, which is about managing the machine learning projects. So, as a problem statement over here, I have picked the Spotify application where I actually like the recommendation engine, where it kind of helps me suggest very nice songs while I am playing, or rather creating the playlist. But I have not seen that happening while I play the songs on regular mode. So from that context, I thought it is a good example where just like how it helps me create a really good playlist based on what songs I added to the list. It would be nice if they can, consider extending that into something beyond, like, which songs to play next based on the user's preference. So that is a problem statement, I've picked up for this particular exercise. So, speaking about the opportunity evaluation, I mean, Spotify has, like literally millions of songs, which is across variety of languages, and it has like variety of users across the globe. I mean, it can be someone who's in US, who likes just the English songs, for example, or someone who is sitting in India and they kind of really like the English songs, for example. So it really depends, you don't have a general way saying that, it's based on the location or, the based on anything like that. So it kind of, has its own, flavor, I would say. So the opportunity for this is pretty huge and it's kind of exciting to, to solve for. From the user concern standpoint, users often find it kind of challenging to discover new songs based on their taste. Like, for example, if I know, let's say Backstreet Boys, and I kind of liked it throughout my life. Unless someone kind of recommends me something new, I don't know much about say something like Green Day, which is a very similar example. Right? I mean, it kind of got released in the same era. So, from that context, we kind of need some sort of, good mechanism to discover new music based on the kind of songs that I kind of played. I think, like if the system can analyze it and recommend me certain songs, I think that would be really great in discovering, new songs and new opportunities for sure. So this can be solved, by a good recommendation engine, is the thought. And the opportunity, like over here, is increased personalization. It increases the user engagement, and of course, the satisfaction and the retention rate. I would say, is going to be increased. And why this can be solved uniquely by them. The Spotify is because they have a rich, amount of data based on which they can kind of train the ML models to understand the user, and their taste and preferences. So we're speaking about the CRISP-DM, the CRISP-DM business understanding. Specifically the problem statement. The goal here is to enhance the user experience on Spotify by developing a recommendation system that suggests certain songs which are most likely, to be enjoyed based on the listening history and the preference of the users, or it can consider similar users across my genre, for example, and kind of based on their history as well. It can kind of recommend me certain songs which most likely will be liked by me as well. So that's the thing. Maybe the next one is the success definition. Speaking about the outcome metrics, so here, the increased user engagement is what we really look for, and high user satisfaction. That is other one, and improved retention rate. So what I mean by that is, like, I mean the stickiness, right? I mean the stickiness of me to Spotify, because it has kept on recommend me, good number of songs, right? So how is that going to happen? How long will I kind of continue to listen? The average listening time, I would say. So how will that change? So all of these things will kind of really come into the picture. A couple of other things, like from the output metric standpoint, the recommendation accuracy, like meaning to say how many number of songs did Spotify recommend me successfully, and I kind of listen to it continuously without kind of skipping it. So were there any recalls? What was the click-through rate? So that is another one. And what was the average listening time? So all of these things, can help me define the success or failure of the algorithm, or the machine learning model basically. So some of the relevant factors that or the features I can consider is what's the user's listening history, like what kind of songs is this person kind of listening all throughout his life. What kind of, I mean, on the other side, speaking about the songs feature, like what is the genre, when was it released, who was the artist, what was the album. So all of those things can also be considered. Any sort of user interaction, like did I fast forward any song, or did I skip any song, or have I come back and kind of repeatedly listen to any particular song. So all of these things can also be considered in by as an input to the machine learning model. So the solution, the concept, at least I would say, is the recommendation system should kind of consider, or rather, it should kind of use a collaborative filtering and context-based, filtering technique to kind of suggest me certain songs. So what do I mean by that? Like it's collaborative filtering in the sense, like, the user behaviors, like, any sort of skips, any sort of repeat mode on, and all these ones. And content based filtering is all about the song attributes, like what I was just saying, right? The artist, the genre, the release timeline, the album, all of these ones, which are the songs features rather, right? So you can kind of filter out based on certain things there as well, and take that into account, while uh, suggesting me certain songs. So all of these things can also be considered. So how do I kind of validate this particular thing is basically, I'll go ahead and probably release it to a small subset of users and compare, how did the recommendation engine perform when compared to the existing one, that is already out there. So I'll try to gather as much feedback as possible from the end users, maybe through the metrics or any sort of usage analytics, and I can kind of get all those ones in and see how we can improve the system. So that would be one of the things. So I'll also kind of do some sort of performance evaluations based on the historical data, like, I mean, how accurate was that? Were there any recalls? So all of these things, the couple of things that, I kind of mentioned over here, in the success definition metrics. So probably I'll, have a look at all of those ones over here as well and try to validate, did I succeed or did I fail? So if I have to kind of design the ML system for this, I've just took the primary parameters which we kind of utilized throughout the learning course. That is cloud versus edge computing, the offline versus online model of training, the batch versus online predictions. So since this is a recommendation engine which is more of a real time, one of the key things is to have minimal latency, and quite it needs to be quite responsive, I would say. So the recommendation engine, we can kind of use a hybrid approach. So meaning to say that, we can do the large batch processing, online, where we leverage the cloud computing, to do certain things at scale, like the model training and so on. So that kind of views a big picture, and, kind of sets the boundary, I would say. And further next, we can use some sort of the edge computing, where, we deliver certain things in real time. I mean, the real time song recommendation happens on the device in real time. And maybe if there is any sort of minor changes, probably we can still accommodate that. But the next day, whenever we have the next batch running, uh, probably things might change based on the history that time. So that is one way. Speaking about the online and offline training model, so again here as well, I would prefer having a hybrid approach, where initially the model is being trained based on historical data in cloud, and offline, like I was saying, if there is any sort of continuous updates to the model that needs to happen based on the user interaction, that can happen in real time, in the online mode. So I would say it's kind of an, it's a mix, of both of the ones. So lastly, the batch versus online prediction. since this is more of a real time, so we need to develop a scalable real time recommendation system, and it needs to have a low latency and high availability. So a cloud-based system, probably will be able to hand something, at this particular scale. So probably, like a cloud-based system would be much helpful, in handling large processing. But in since there are certain things that has to be handled in real time as well, so we'll have to take that also into the account. Some of the risks, I would say, in production, I would say is that any sort of skew that is happening in the training data and the actual real-time data that we anticipate. So I think there needs to be some sort of consistency to avoid any sort of discrepancies in the model performance. I mean, again, since this is a real-time recommendation engine, there has to be minimal delays. So the latency plays a key role, and any sort of data drift, like the continuously we need to monitor and update the model to handle new changes on the user behavior and so on. So that needs to be taken care, without which the model is going to fail over time. So uh, continuously we'll have to monitor the drifts in data, and we'll have to keep ensuring the model is updated accordingly. So with that, we'll come to the end, and thank you for that one.